Hello everyone, welcome to Gchem classes. So today the third part and final part we are going to discuss for coordination chemistry. I'll discuss just inorganic spectroscopy. In that term symbol I'll discuss, oracle diagram I'll discuss, and then directly we'll move to the questions. In that questions, if any new type of questions is arriving, means new concept is arriving, we will discuss there itself, right? Whatever the concept is required for that, we'll discuss it and we will finalize. So one more thing, like if you are getting help from these classes, kindly comment it, okay? And what all improvement you require, you just tell me in the comment box, I'll do that, okay? And we are announcing a new batch, okay, for IIT JAM 2024. That will be start from 13th February, okay? If you are interested, you can join there, okay? And we will learn it and we will grow. Okay, so now it's starting coordination chemistry. Let's see the inorganic spectroscopy, right? Correct. So first we will discuss the microstate. Okay, and possible term. Okay, microstate and possible term. So what is microstate? Okay, we'll discuss first microstate and the possible term, right? So what is microstate? That we have to find out. Like suppose one electron is there in P. Just we'll see in P one electron is there. So what are the possible arrangement for this particular electron, that we will find it out in the microstate, right? Suppose P, how we are writing? So this is one P. Okay, this plus 1, 0, minus 1. Okay, then first electron will be in this box. Okay, plus 1. Then second possible will be plus 1, 0, minus 1. Electron can be in this place. If one electron is there, that may be the possibilities, right? Whatever I am drawing here. Okay, these are the possible. So possibilities is only the microstate. Okay, whatever the possible way of arranging a electron, that is only microstate. So we have to find it out how many microstates are present in P1. So after that I'll give you the formula. Okay, so plus 1, 0, minus 1. So electron can be reside here, and then again plus 1, 0, minus 1. Electron can be reside in this way, anti-parallel. Correct? Then this is plus half, this is minus half, right? Plus 1, 0, minus 1. Electron can be reside here. Then next possible is electron can reside here. So total how many microstate or how many possibilities are there? How many arrangement are there? 1, 2, 3, 4, 5, 6. So total how many arrangements are there? 6. So for P1 the number of microstate is 6. Okay. If anyone says, like if it is saying that P1, what will be the number of microstate? The number of microstate is 6. So how we are going to draw for microstate, number of microstate? For any number of electrons or any for any orbitals, what we are going to see? This will be n factorial. It will be n minus r factorial into r factorial. So here what is the n? N is number of orbitals for that particular, suppose you are taking for P, right? So P, how many orbitals are there? 3. So number of orbitals into 2. So 3 into 2. If you are talking about d orbital, so how many orbitals are there? Number of orbitals in d is 5 into 2. So total it will be 10 and then factorial. Okay. And what is r? R is number of electrons. Okay. R is number of electrons. Okay. So capital N is number of orbitals into 2 and R is number of electrons. So first we will see for this only whether 6 it is coming or not. Okay. So for P1, n factorial, how much it will be? Number of orbitals, how many orbitals are there in P? 3 into how many, 3 into it will be 2, so it will be 6 factorial. Directly what we will do, we'll just write it here, and then next time onwards that won't be require to calculate each and every time. If it is P starting from S, if it is S, it will be 1 into 2. If it is P, it will be 3 into 2. If it is B, it will be 5 into 2. If it is F, it will be 5 and then it will be 7 into 2. So it will be 14, correct? So now directly we will fill it out. For P it will be 6. We are not going to multiply here because it will be make your equation more complicated. So n should be, here it is for n, right? So for P it is 6 and then here factorial because n factorial, right? Divided by what is the n? N value is 6 minus how many electrons are there? Only one electron are there. So factorial into R means how many electrons are there? 1. So 1 factorial equal to, we know that factorial means 6 into 5 into 4 into 3 into 2 into 1, right? So just we will do it 6 into 5 and then factorial. No need to open everything, like no need to write 6 into 5 into 4 into 3 into 2 into, because we know that down where we having 6 minus 1, right? Here we have 6 minus 1, so it will be 5 factorial, correct? 6 minus 1 is 5 and then factorial into 1 factorial. 1 factorial is nothing but 1 itself. So what will happen? This 5 factorial and this 5 factorial will get cancelled. This 1, it is, this 1 means if you are dividing anything with 1, it will be 6 only, right? So 6. See the number you are getting for P1, number of microstate is 6, right? So 1, 2, 3, 4, 5, 6. So these are the possible arrangement microstate we are finding. For D, we will find it out, okay? Let's see for D how much it is coming. One term symbol like this possible microstate they will ask. Definitely they will ask one possible microstate. Easily you'll get 1 marks or 2 marks, okay? It is not that much complicated. If anything particular problem where you are not able to solve for number of microstate, let me know, I'll discuss with that, okay? Because these are the free marks you will get it, correct? So for D we will calculate. Suppose for D1 and we know for D we have written here for D it will be 10, right? And n value, capital N value will be 10 because D orbitals are 5. 5 into 2 it will be 10. So now number of microstate, how many will be there? So it will be n factorial divided by n minus r factorial into r factorial, correct? How much it is coming? N equal to, here it will be 10 factorial divided by, it will be 9 factorial into, here it will be 1 factorial, correct? So it will be 10 into 9 factorial divided by 9 factorial into 1 factorial. Cancel it out, so it will be 10, okay? Number of microstate is 10. Suppose you are solving for D2 or P2, whatever you want. Suppose you are solving for D2. So how it will work? So here it will be 10 factorial, here it will be n minus 2. So 8 factorial into, here it will be 2 factorial. So it will be 10 into 9 into 8 factorial divided by 8 factorial, because we can open it. You just open it till where it will cancel it out, okay? Otherwise you will open till 1. Here also you have to open till 1 and then it will be more complicated, right? So work in a smart way, correct? Now it will be 2 factorial, so it will be 2 into 1. 2 into 1 factorial, correct? So now see what is happening. 8 it will cancel out. 2 it will be 5 and 5 9 it will be 5 9s are 45. So 45 microstates, okay? For D2 it will be 45 microstates, okay? Likewise one F, I'll solve it. For F1 it will be 14 factorial. 14 means 7 orbitals are there into 2, right? 14 factorial divided by 14 minus 1. So it will be 13 factorial into 1 factorial equal to 14 into 13 factorial, and 13 factorial get cancel it out. 1 factorial, it will be 14. Number of microstates are 14. Okay. Likewise for P3 also you can find it out. P2 also you can find out. For P6 also you can find it out, correct? So for P6 we'll see how it will come. Means all the orbitals are filled up, okay? Let's see what will happen for if all the orbitals are filled up, whether any arrangements are possible or not, whether any space is there to possible microstates. Let's see. For P6 it will, we know that for P it will be 6 factorial divided by, we have n minus r. So n is 6 minus how many electrons are there? 6, correct? Into, here it will be number of electrons 6, so 6 factorial. Now you see what is happening. So 6 factorial divided by 6 minus 6, 0 into 6 factorial. Once we got 0, everything will be 0. So number of microstate is 0, correct? So that means if this is the p orbital, plus 1, 0, minus 1, if you have completely filled, what will be the number of microstate? it will be 0. Whether you for D also you take D 10 and C, your number of microstate will be 0. For F, you take F14, your number of microstate will be 0. It means there is no space to perform this arrangement, right? So if there is no space to perform this arrangement, then we don't have microstate, okay? So it will be 0. So this is the microstate term. Now number of microstate we have already calculated. Now directly we will go to the term symbol. Okay, what is the term symbol that we call the spectroscopic term symbol? Discuss atomic term symbol, correct? So in this atomic term symbol we have to like see some conditions, some rules are there to find out this atomic term symbol. So orbital number we have to find it out, then we have to find it out the spin multiplicity, okay, and then probable J values, okay. Based on that, one term symbol will arrange, and that term symbol might be, many times they have asked that what will be the term symbol for D2, what will be the term symbol for D1, right? So suppose I am taking 2P2 or P2, whatever you want, P2 you take it, and then you have to fill it up this P2 first. So for possible L value, L means your orbital value, okay. So now the orbital value you have to find it out. Let's see for P how much it is coming. This is +1, this is 0, this is -1, okay. P2, so 1, 2. Now what you have to do it, L equal to whatever the numbers will come, you have to add it up, right? So this will be +1 and +0, okay. So how much it is coming? This +1 +0, how much it is coming? 1. So 1 means what? I'll just write it down here. 0, 1, 2, 3, 4, and L value will be S. These are capital, okay. P, D, S, P, D, F, okay. It will go like G, okay. So now S, P, D, which one is coming? 1. 1 means it will be P. So now this is the basic term P. We have to arrange the spin multiplicity. Here it will be spin multiplicity, here will be J value, okay. So let me find first spin multiplicity. Okay, spin multiplicity, how much it will come? So what will be the spin multiplicity here? So first we have to find it out S, because we know that 2S plus 1, okay, this will be the spin multiplicity. So first S we have to find it out. So S will be, here it is +½ plus this will also +½. So how much it is coming? 1. So here it will be 1, right? So 2 into 1 plus 1. So how much it is coming? 3. So 3 if it is coming, we have to put it here 3. Now the J value we have to find it out, right? So J, we know that if your orbitals is less than half filled, it will be L minus S, and if it is more than half filled, it will be L plus S, okay. So now it is less than half filled, so L minus S, right? So what is the L value? L value we got it 1, and what is the S value we got it? S value is 1, right? So 1 minus 1, so it will be 0, correct? So the term will be 3P0, okay. This will be the term. Likewise we have to calculate for term. We have PYQs, there we'll see how we are calculating, correct? So it is not that much difficult, okay. It is very much easy. The term symbol, if it is coming, you just calculate it, okay, and put the values, because they will give 4 options, okay. So there is no space for confusion, correct? And then number of microstate. So either microstate or term symbol, they will ask any one question, correct? So one question is fixed for you, where you are going to solve it correctly, correct? So make the confidence, okay. Every day do practice and make those confidence and get solve your paper, right? So now we'll see the oracle diagram, correct? Okay, just we'll see oracle diagram, okay. And this is the correlation chart, okay. So we'll see the correlation chart or oracle diagram, whatever is there. So before that, we need to know the basic terms, okay, basic term symbol, the correlation diagram and molecular term, right? So suppose in correlation diagram, what I'll do, directly I'll start the correlation diagram, because whatever is required for this upcoming examination, let me do that much itself, and then in detail we'll see, okay, later part, okay, because again you will get confused. Now the thing is that in your place you should able to solve the problems, correct? So likewise I'll make the things. So just basic thing I'll put and then we'll start for oracle diagram. Before that, this is T2G and this is easy. Just let me draw first and then I'll explain you what I am drawing. Okay, suppose you have D1 configuration. So you know that T2G 3 orbitals are there and EG 2 orbitals are there. So 1 electron is there. So this will promote. Okay, so if this is going up, so what is happening? This we call it electron promotion. Okay, electron promotion. So now what is happening? Let's see. This electron is get promoted here, right? So this is electron promotion. Correct. We have D9. Correct. So in D9, what is happening? This is T2G. This is G. And one more thing, this correlation diagram will work only for high spin complex. Correct. Only for high spin. Whatever I am drawing now, that will be for high spin complex. In your examination, IIT JAM examination, it won't make complicated. So you just look into these pictures and then based on that, I'll just draw a diagram, and in that diagram, only P term, only D term I'll draw it. Okay, not P term, only D term I'll draw it, and for F, it is not required. I guess if any problems are there, PYQs for F term, definitely I'll do that. Okay, if it is not there, only D term only I'll draw it. Okay, because F term again like opposite to this D term, correct? So now you just see how we are working here. So for D9 high spin 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now if any one electron is getting promoted from here to here, what is happening? Hole formation. Because this is completely packed, right? And one electron is moving. It means here it is creating hole, correct? Here it is creating the gap, hole, correct? So how it will look? T2G, EG. So see, this place it is created hole, ठीक है? So अभी जो है हम लोग नेक्स्ट फिर देखेंगे. अभी तो ये 2 हुआ है. अभी हम लोग देखेंगे D4 का और D6 का, है ना? उसमें क्या होता है D4 एंड D6. लेट मी चेक. ओके, D4 T2G EG, T2G EG. Why I am explaining this, you will come to know, and it will be very much easy then, because directly if I give diagram, then you will feel that what it came, right? So पहले अगर हम ये डोज दे देंगे आपको, बाद में डायग्राम बनाएंगे तो आपके लिए वो इजी रहेगा, है ना? जितना आपको जरूरत है इस अपकमिंग एग्जामिनेशन के लिए, मैंने उतना ही छोटा करके, लेकिन ट्राई किया हूँ कि उसको एक्सप्लेन करके आपको बताऊं, है ना? ऐसा नहीं है कि सिर्फ बना करके सॉल्व कर दिया. हम तो नहीं जा रहे हैं ना एग्जाम में बैठने के लिए, आप जा रहे हैं, करेक्ट? सो फॉर यू आई एम सॉल्विंग दिस, करेक्ट? सो इन दिस केस हाई स्पिन, राइट? सो 1, 2, 3, 4. So there are 4 electrons. Now what will happen? One electron will migrate. So what is happening? This electron is moving there. So it will be like this, and in down 1, 2. And here what is happening? Hole formation. Okay. And for D6, how the thing is happening? I'll just explain you. I know you are getting confused. I'll just explain you how I'm giving this explanation, whether it's a hole formation or it's a electron promotion. Let me finish, then I'll tell you. Okay, so what is happening now? D6, right? 1, 2, 3, 4, 5, 6. This electron is going there. It means it is electron promotion, correct? So 1, 2, 3, 4, 5, 6, correct? So here it is electron promotion, here it is hole formation. What is happening? Just you remember one thing. If anything from symmetry, okay, symmetry to unsymmetry, okay, if any orbital is in symmetry and it is after taking out the electron, if it is unsymmetric, then there we call it hole formation. Okay, and any unsymmetric orbital, just keep it in mind, any unsymmetric orbital after taking out the electron, if it is symmetric, then in that it will be electron promotion. Okay, because promotion, always many people, all people like promotion, right? So if from unsymmetric, if taking out of after taking out of electron, if you are getting symmetric, then it will be electron promotion. If from that orbital, if you are taking out the electron and it will become unsymmetrical, then it is hole formation. Just apply this here. Now this down 1 1 1, 3 electrons are there and these orbitals are symmetric. Correct? This is symmetric. After taking out of this electron, what about this? This is unsymmetric. Correct? So symmetric to unsymmetric. So symmetric to unsymmetric, it is hole formation. Right? It's a hole formation. Now coming to this point, we know that this is unsymmetric. Right? D6 is unsymmetric because 1, 2, 3 and 4. So if it is, it will be symmetric when this electron will be promoted. Right? So this is now unsymmetric. Correct? This is now unsymmetric. After taking out of this electron, this becomes symmetric. See? This becomes symmetric. So from unsymmetric to symmetric. Okay? From unsymmetric, suppose your orbital is unsymmetric, after taking out of electron, if it will become symmetric, then it will call electron promotion. Correct? Then it will become electron promotion. So now you come to know, right, hole formation and electron promotion. So hole formation and electron promotion. So next time maybe they will ask for D4, the electron transition will be hole formation or your electron promotion. So you can explain by this. Okay? Correct? Now directly we'll go to the correlation diagram and we'll see how it is working. Correct? Let's see. I guess you are enjoying. If you are enjoying, just put a like, right? The diagram. Okay, this side it will be for D1 and D6. This side it will be D4 and D9, because we saw that for D1 and D6 what is happening? Electron promotion, and for D4 and D9 it is hole creation, right? Hole creation or hole formation, right? And we told and already I have informed that I'll discuss about this term, okay, D term. Okay, so now what is happening? Okay, this will be the term, like term symbol. I'll just draw and then I'll explain you. Here it will be T2G, here it will be N, to EG, here it will be N. This side, this E, you just write it in capital. Okay, this side it will be from EG to T2G. Correct? If suppose for D1, I'll just discuss one example. Okay, it is not like that. Just you see this diagram. So this Oracle diagram, so if you are going to fill up this Oracle diagram, so what you need, you have to find it out first, this term, right? We have discussed, right, term for P1 or P2. P2 we have discussed the term, right? For P2 how much it was there? 3P. So suppose if it is 3P, so likewise we have to put it here. So suppose for D1, okay, just we are calculating. Suppose for D1 what will be the ground term? For D1, let me check. Okay, so plus 2, plus 1, 0, minus 1, minus 2. So plus 2, 1 electron is filled up. So L value is plus 2. Okay, it means 2. 2 means term is D. So D term we got it. So we are discussing only D term here, right? So D term you got it. So spin multiplicity, because this N also we have to find it out, right? So spin multiplicity. So first we have to find it out S. S is like your only plus half. Now spin multiplicity you have to find out. Spin multiplicity, how much it is coming? It will be your S plus 2S plus 1, right? So 2S plus 1. So 2 into half plus 1. So it will be how much it is coming? 2 and 2 it gets cancelled. So 1, 1, 2. So 2 you are getting, right? So if you are getting 2, then it will be okay. Then N will become 2. So it will be 2D. So here you will put 2D. Okay. And now what is the ground state term? Okay. This is the term symbol. This is the term symbol. Now what is the ground state term for this spectra? This will become ground state term. Means you have to write, okay, because D1, okay, D1 means you have to see this side picture. If it is D4 or D9, you have to see this side picture and your ground term will be EG. So now if they are asking what is the ground term symbol, GTS, ground term symbol, you have to write, here it is N equal to 2, right? So 2T2G. This will be your ground term symbol. If they are asking only term symbol, atomic term symbol, 2D, correct? It will happen from P to G to EG, it will happen, okay? So likewise for D4 we will take it and we'll solve it everything, correct? Now I'm just rubbing it up, and for D4 we will see it, what will be the term, what will atomic term, what will be the microstate, and what will be the ground state term symbol, right? So this side you just forget it for time being. We'll see for D4 if anything is in D4. So first of all we have to just calculate it. Everything is high spin, okay? 1 2 3 4 5 plus 2 plus 1 0 minus 1 minus 2, so 1 2 3 4. Okay, now you have to find it out for L value. L value will be plus 2 plus 1 plus 0 minus 1, so minus 1 plus 1 will get cancelled, so L equal to 2, right? So L equal to 2 means it will be D term. See, again we got D term. Now you have to find it out spin multiplicity, right? So spin multiplicity will be like 2s plus 1, right? So what will be the s value? So it will be plus half plus half plus half plus half. How much it is coming? 1 2 3 4. 4 into, I'll just here only I'll do it. 4 into 1 by 2. So it will be 2 and then plus 1. So how much it is coming? 2 to 4, 4 and 1. It will be 5, right? So your term will be 5D, correct? Now 5D. So atomic term is 5D. And what will be the number of microstate? Microstate you have to find, this is D term, right? So it will be 10 factorial divided by 10 minus 4, because R equal to 4. So 10 minus 4 it will be 6 factorial into 4 factorial, right? So this you have to solve it. So 10 into 9 into 8 into then 7 into 6 factorial, correct? Because down it is 6 factorial is already there, into 4 into 3 into 2 into 1. You have to just write it down. 6 factorial is getting cancelled. 4 into 2, 3, 2 get cancelled. So it will be 70, 210. I guess I'm correct. My mathematics is weak. So just verify it, okay? I think 210 microstate. So number of microstate is 210 for D4. Just calculate it, whatever it will come, that many microstate will be there, okay? Now the thing is we have to find it out the spectroscopic term, right? The transition, okay? From where to where it will go. So this is 5D and now this is a D4. So D4 means if any electron is going, just do it like this, T to G, EG. 1, 2, 3, 4. Now you just see, this is symmetric, okay? And we know that from symmetric, if any one electron is getting promoted, then it will form unsymmetric. If from symmetric to unsymmetric it is forming, we call it hole creation, okay? Hole formation. If it is hole formation, then the basic term will be EG. So this will be like EG to TTG. Now your spectroscopic ground term symbol, GTS ground term symbol will be N. N is 5 EG. Okay, ground state term symbol will be 5 EG. Okay, so this is this much easy, right? It is very much easy. Only the thing is you just do practices, okay? Now you just put different type of examples. I've just solved for D1, okay? And D1, D6, D4, D9, okay? Just do practices. This side it is electron promotion. This side it will be hole creation. Hole creation or hole formation, correct? So these are the basic things which I have discussed. Now directly we will take up the examples, correct? Okay, directly we will take up the examples. If any new things are coming, we will just discuss it there itself and then we will solve it, correct? Question number 18 from 2022. Okay, from 2022, question number 18. You can see it's for 2 marks, right? They have asked, you can see in the screen, the ground state and the maximum number of spin allowed electronic transition possible. So just I'll write what they are asking. Ground state term symbol, okay? So GTS, ground state term symbol, they are asking what will be the ground state term symbol and maximum number of spin allowed. So number of transition they are asking, electronic transition, okay? Number of transitions they are allowed, asking, okay? So the D term won't work it out here, right? We have to find the F term because in D term only one transition is there, correct? And then we have to find it out what will be the ground term symbol. So it is better that you already learn in concept like in wherever I was giving you the concept, that particular time you learn for D term. Now we'll see the F term, right? So the transition possible in cobalt 2 plus, and you have learned for octahedral, right? Here we'll see for tetrahedral. Okay, cobalt 2 plus in tetrahedral complex. Okay, so we have to find it out. So just first we'll see the concept and then try to solve this question. Okay, so for F term, okay, along with the F term we should have P also. Okay, because this is the ground state and this is the excited state. So what will happen for F term? 1, then 2, 3 and 1 P term. So it will start from, for F term it will start from always N A to G, and then here it will be N T2G. N will be the multiplicity, correct? Whatever the multiplicity will come here, that we are going to put it, and then here it will be N T1G. In bracket you have to write F, and then here it will be N T1G. In bracket you have to write for P, correct? And spin crossover also it will happen here, but which side? This side. So here now it is for D term, so for F term, for octahedral complex it will be hole formation, okay, and for and this side it will be electron promotion. Okay, so this side we are going to write for hole formation, because hole formation and hole formation and electron promotion already we have explained for D term. It will be similar, right? Whatever the hole formation and electron promotion, this side it will be electron promotion. And how it will be? So again this will be reverse, okay, and this will go up and this will be like this. Okay, so the transition will be, here it will be T1G and T1G, and this is for F, and this will be your T2G. It won't change. This will be your T1G and T1G, and it will be for P, and this one will be your A2G, and this will be for your like here it will be N, and this will be for F term. No need to write A2G, because A2G we know that it is for F term only. So this is the basic thing. Okay, whether you are forming for octahedral or you are forming for tetrahedral, this is basic thing. Okay, for D3 and D8, okay, D3 and D8, if it is octahedral then it will fall this side. Okay, if it is D2 and D7, if it is D2 and D7, for octahedral only I am talking, it will fall this side. Similar way, if it is D2 and D7 for tetrahedral, it will fall that side. If suppose if it is what is that, D3 and D8 for tetrahedral, this will fall this side. So it is very much similar. Whatever octahedral it is falling this side, opposite will be for tetrahedral. Similar way, here for octahedral whatever is falling this side, the opposite will be for tetrahedral. Okay, so it is very much easy. Now you have to say that electron promotion and hole formation or hole creation also. Now it is very much clear, right? Because already we have explained. Go and watch that particular, like you just like rewind back and just see how we have explained that one, because today's lecture only I have discussed that one. So now this is for F term. That D term also we have explained. So next time if they are asking for D term, that also you can solve it, right? So now what we have to do, just now for cobalt 2 plus we have to start solving, correct? And it is for tetrahedral, right? So tetrahedral, what we have to do, tetrahedral is not Girardi, right? So all the G you have to remove it. For tetrahedral, all the G you have to remove it, correct? Now for cobalt 2 plus, how many electrons are there? D7. So by seeing D7, you just see it is falling this side. Immediately your GT as ground term symbol will be A2. And N, number of, the N we have to find it out, right? So for that L we have to calculate it. So just, it will be in high spin, 1, 2, 3, 4, 5. So D7, right? Plus 2, plus 1, 0, minus 1, minus 2. So 1, 2, 3, 4, 5, 6, 7. Now for L value, how you are going to calculate? Entire thing you just do plus. So it will be plus 2, plus 1, plus 0, minus 1, minus 2, plus 2, plus 1. So these many electrons are there. Just calculate it. So plus 2, minus 2 will get cancelled. Plus 1, minus 1 will get cancelled. So plus 2 and plus 1. How much it is coming? 3. So 3 means it will be F. right? So F term we got it. So if you are getting F term, then only you are going to solve by this oracle diagram, okay? If you are getting D term, then the simplest way, T2G, EG and E, EG and T2G, okay? That one you are going to solve it, correct? So now it is F term. Now the multiplicity we need here, right? Because this N number we require, right? What will be this value? N value. So in F term, multiplicity we have to find 2s plus 1, okay? This will be the number of this N value will come here from this calculation. So let me check first S will be like plus half, minus half, minus half. This already got cancelled, 0 0. Here it will be plus half, plus half, plus half. So 3 by 2. So this will be the S value. Now just put this S value, 2 into 3 by 2 plus 1. So 2 will get cancelled out, it will be 4, right? So your ground term symbol, I'll just write it here. It will start from this, because D7, it will start from A. So G won't be written. So A2 and then N value will be 4, because we are getting here 4, right? So it will be 4F. So 4. So this will be your, which option it is having? 4A2. 4A2. Okay, only one option, like first option is itself correct, but we will solve the second part also, that 3. How the 3 is coming? Let's see. The transition, number of transition. From ground state, sorry, it is not this side, it is this is the ground state, right? So this is the first transition, then this is the second transition, then this is the third transition. So total how many transitions are possible? 3. So number of, this is A to G, okay, I'll write, it is N. So number of transition is also, we got it, it is 3. Next time what they can ask, they might be asking this, tell me the transitions from where to where it is going. So it will be, first transition will be A2, okay, 4A2 to 4T2. Second transition will be 4A2 to 4T1, 4T1, and you have to write it here F. And third transition will be 4A2 to, where it is going, 4P1, and it is for P term, P, right? So 4A2, these are the 3 transitions. Next question might be they are asking which transition is having higher wavelength and which transition is having lower wavelength, arrange it. So see the energy, this is the energy, this one, like whatever we are going from down to up, it is energy, right? So this is having lesser energy, the transition 1. This one is having lesser energy, means the wavelength will be more, because energy is inversely proportional to wavelength, right? So here wavelength will be more, this wavelength will be again lesser, and this will be lesser wavelength, right? So any type of question they might be asking, just play that logic that energy is inversely proportional to wavelength. If they are asking arrange based on energy, then energy wise it will be like your third transition will be more energetic than second, then first, right? First will be the least energetic. Wavelength wise, first will have more wavelength, then second, then third will have least wavelength, right? So likewise they may ask you the questions. So this is the oracle diagram for F term, correct? So we have completed the F term also. For this question, question number 18, option A will be your correct answer, correct? Now the question number, what we have, 20. Okay, we'll see for the same year, question number 20. So you can see in the screen the question. Okay, so question number 20, what it says from the same year, question number 20, the order of increasing CO stretching frequencies. Okay, carbonyl stretching frequency they are asking. Okay, carbonyl stretching frequencies in cobalt, copper, iron and nickel is given. So carbonyl is contributing 0 charge, right? It is only lone pair is getting filled in the metal center. So whatever charge is given in that bracket, that will be the oxidation number. So I don't know why they have given for iron -2 charge, -2 oxidation number, and cobalt minus. Maybe they want the stretching frequency. In this type of question, just I write down all the compound complex CO4 minus, and then copper, okay, copper 4 plus, and then iron, carbonyl 4 2 minus, and then nickel, carbonyl 4 no charge. Okay, so directly we can calculate the oxidation number. Okay, so cobalt it will be minus, then copper it will be plus, and then iron it will be -2, okay, or 2 minus we can write it, and for nickel it will be 0, okay. And we know that as charge increases, the positive charge, as charge increases, the stretching frequency will also get increased, correct? Question is asking order of increasing stretching frequencies, okay. As the charge increases, we know that as the charge of the central metal, okay, Cm, central metal increases, the stretching frequency, as the stretching frequencies also get increased, okay. These are the small points, just write it down somewhere, it will help you out, okay. So directly you will see the charge increases with the lower charge, means the positive charge means the positive charge they are saying, okay. So what is happening, this will be the least stretching frequency, this complex will have least stretching frequency, so just write it down 4, because this is 2 minus, right? So then which one will have lesser charge? Cobalt, okay, carbonyl 4 minus, and then which one will have nickel, because there is no charge, nickel 4, and then which one will have copper, because this is only the positive one, okay, right? So copper and then carbonyl 4 and positive charge. This, just find it out which option it will have. Option B, right? Option B. So option B will be your correct answer, okay. So we'll see the next question. So this question will solve it. It is very much easy. Question number 29. Okay. So in question number 29, what they are asking, just see, don't try to solve the questions. These questions they are not going to ask you, but during solving, try to learn the concept, because they might be asked the similar concept. They will change the examples, correct? So question number 29. See, it's already I discussed in a concept the number of carbonyl stretching bands in an infrared spectrum. So number of carbonyl stretching band, right? So this you have to see whether all the bond length are similar or not. If the bond length are not similar, then there will be two type of stretching frequencies. If the bond length is not similar, then two type of stretching frequencies you will get it. If bond lengths, all the bond lengths are similar, only one stretching frequencies it will be there. So they are given the complex iron 5, right? So just try to draw it. This is iron, okay. This will be trigonal planar, and then one will be in axial side, okay, another one will be in downside. So this will be the trigonal planar, and then this is the pyramid, okay. So TBP, trigonal bipyramidal. So this one will be in a plane, this carbonyl is in up, this carbonyl is in down. So what is happening, this is the equatorial bond, okay, EB, equatorial bond. This one is axial bond, AB, okay, axial bond. Now this equatorial bond and axial bond are not similar, because this is a larger molecule, correct? This is a larger molecule, and here the fluxional behavior it won't show. Okay, next time maybe they might be asking in which of the molecule the fluxional behavior is taking place. Okay, what is the fluxional behavior? If this one is a smaller molecule, what will happen? This exchange will take place. Okay, this molecule will go there, this molecule will come here, this molecule will go down, this molecule will go there. So likewise, this changes will happen, okay, in room temperature. So which molecule will show fluxional behavior? So PF5. Okay, suppose it is iron and F5. This molecule, because fluorine is a smaller molecule, smaller atom, right? So in that fluorine, what is happening? That will be continuously changing its position, right? In room temperature, okay? In room temperature, continuously it will change its position, and that we call fluxional behavior, okay? So in carbonyl, if it is carbonyl, the molecule is heavier and the fluxional behavior is absent in room temperature, right? If it is absent, then these three will show one type of stretching frequency, and these two will show another type of stretching frequency. So suppose this is A type of stretching frequencies, all the three will give A type of stretching frequencies, and this B and B will give another type of stretching frequencies. Total 2 stretching frequency will be available in this type of molecule. Suppose they are asking PF5 or FEF5, okay, if they are asking this type of molecule, then only one stretching frequency will be there, okay, only one type of stretching frequency will be there with this iron, correct? So this question, which option will be correct? Option B. Okay, option B will be your correct answer. Next question, we'll see it. Okay, question number 35. Let's see. It is also a good question. From reaction mechanism they have asked. So you should know little bit reaction mechanism also. Then only you will be able to solve this type of question. So question number 35. They have given particular reaction rhodium, okay, and then PPS3. Okay. These are the away from the observer. This is towards the observer. And this is also towards the observer. Okay, means this hydrogen and this phosphine and this chloride is in plane. Okay, so one chlorine is towards you, one phosphine is towards you, and remaining hydrogen is back towards the board, and this hydrogen is also towards the board, right? Now one more is there. And now what is happening after reaction? Just see after reaction what is happening. Hydrogen, chlorine, this is away from the observer. PPS3, right? Phosphine, triphenyl phosphine, correct? It is a heavier molecule. Okay, triphenyl phosphine. And now, okay, this is methyl. So what is happening here? First of all, the migration is taking place. Okay, so it is just directly it is attaching here, and whatever the charge is coming here positive, this hydrogen is coming and sitting over here. So here the migration is taking place. First the migration is taking place, okay, and what all it has asked, the reaction involves, okay, migratory insertion. Okay, migratory insertion, option A is correct. Please just write it down. Then option B, change in electron count from rhodium 18 to 16. Valence electron we have to calculate. So first for this molecule we will calculate, and then we will calculate for this. So for rhodium, total valence electron is 9, plus this chlorine will contribute 1, this hydrogen will contribute 1, this hydrogen will contribute 1, this phosphine will contribute 2, this phosphine will contribute 2, and this is the double one, right? So pi bond is involving, right? So here also it will contribute 2. So how much it is coming? 2, 2, 2, 6, 7, 8, 9, 9 and 9, 18. Okay, here 18 electron it is coming. Towards, like, for this molecule we have to calculate. Again for rhodium it is 9, plus this is contributing 1, this is contributing 2, this one is contributing 2, this one is contributing 1, this one is contributing 1. So how much it is coming? 9, 1, 10, 12, 14, 15, 16. So 16. So your option B, change in electron count of rhodium from 18 to 16. Yes, it is correct. Okay, 18 to 16 it is changing. Then option C, oxidative addition. No, it is not oxidative addition, because there is no oxidation number is changing. Okay, oxidation number is not getting changed. Okay, so change in electron count from rhodium from 16 to 18. No, it is not from 16 to 18. It is from 18 to 16, right? So option D is also not correct. So only option A and option B, these two are correct for this MSQ. Question number 35. Okay, let me see if any other questions are there from this particular year. Okay, question number 46. Let me see what they are asking in question number 46. You can see in the screen, right? And try to solve. Okay, by the time I am solving, you also try to solve the same questions. The number of unpaired electrons, it is very much easy. Number of unpaired electrons they are asking in this molecule, H2O, and then 6, this is 2 plus. Okay, how much it should come, that we have to ask. That they are asking, right? So number of unpaired electrons, so for that we have to see this is a weak field ligand, correct? So whatever the oxidation number it is written here, the same oxidation number will be for cobalt, right? 2 plus. It means it is D7. If it is D7 and it is weak field ligand, so it will be high spin complex. So T2G, and here it will be Eg. So we know that 1, 2, 3, then 4, 5, 6, 7. 7 electron we have saved, correct? Now we have to see the number of unpaired electrons. So 1, 2, 3. So number of unpaired electron is 3. Next time they might be asking what is the magnetic property, it's a paramagnetic. Okay, so what is the Bohr magneton value? So it will be 3 point how much, 83 or 87 it was, right? So Bohr magneton. So likewise you do practice by yourself. This is the question number 46, right? Question number 46. Then if there are any other questions from this year? Okay, question number 54. There are many questions from coordination chemistry, right? So this is the backbone of your IIT JAM exam. So try to solve many questions from, like, practice this coordination chemistry. Whatever I have given you from past 2 lectures and today's lecture, it is enough to at least whatever questions. Suppose they are asking 10 questions, easily 9 questions you will solve it. Okay, I can't promise that out of 10 questions you are going to solve it. If they are asking 10 questions, I'm sure based on this concept you will solve the 9 question. Surely you will solve it, correct? So because I have created like whatever the question I have seen, based on that those concepts I have chosen, right? So because it is not enough in 2-3 lectures you will complete entire coordination chemistry, correct? Then it will be like within 1 week all the chemistry will get over. It is not like that. Okay, so next question is question number 54. It is also an NAT type question. The total degeneration number of microstates. See, number of microstates they have asked for titanium 3+. So titanium 3+, they are asking number of microstates. So we know that scandium, titanium. Okay, so metal in +2 state, D1, it is D2, correct? Now if this metal is in +3, so again it will be D1, right? This is metal in +2. Okay, so this will be for titanium, it will be D1, correct? Asking, so for D1 it will be, we know that for factorial how much it is coming? 10 factorial divided by 10 minus 1 factorial into 1 factorial. It is this much easy. Okay, 10 into 9 factorial divided by 10 minus 1, 9 factorial into 1 factorial. 9 factorial will get cancelled, so it will be 10. So number of microstate is 10. So just fill it up, 10, your answer is done, right? So from this year there is no more questions. Okay, so see, we have solved around 6 questions from 2022. Okay, I'll take for 2021. Okay, we'll see the 2021. So from 2021 we are taking questions now. Let's see what all questions are there from 2021, correct? So from 2021, okay, question number 3. You can see in the screen, they are asking spin only magnetic moments in Bohr magneton. Okay, in bracket they have written in Bohr magneton. For the complex they have given nickel, then Cl2, then PPH3, how many are there? Twice, and 2 complex they have given, and for both the complex you have to calculate the Bohr magneton value. Okay, NCS, and then 6. Here it is charges 4 minus, okay, respectively. So you have to just find it out the number of unpaired electrons, okay, in these 2, correct? So for first one we will take it, what will be the oxidation number, and based on that the number of unpaired electrons will be there. Okay, PPS3 here strong field ligand is there, correct? PPS3 will be strong field ligand, this is weak field ligand. Here also it is not a strong field ligand, it's a weak field ligand. Okay, this is weak field ligand, this is a strong field ligand, this one is weak field ligand. Okay, if it's strong field ligand and weak field ligand together it will be there, the leader will be strong field ligand. Okay, so now for nickel we'll see it, what will be the oxidation number for this complex. So X plus, we are discussing for nickel, X plus 2 into minus 1. Here the contribution is 0 because lone pair is contributing, right? So we are not going to write, simply it will be 0 because nothing is mentioned here. So X barabar plus 2. So nickel it is in plus 2 state. So now plus 2 state it will be D8, correct? E and it will be G, and E and it will be, okay, T2. It is E and this one is T2. Here it will be 2 orbital, here it will be 3, right? And one more thing, so it means this one is octahedral and this one is that we have to see tetrahedral, because now there is no strong field and weak field, because it will act as a, if it is tetrahedral then it will be act as a high spin complex. Always it will be in high spin complex. Okay, so just write, fill it up, 1, 2, 3, 4, 5, 6, 7, 8, correct? So it will be high spin. So now the remaining 2 electrons are there. Okay, so this 2 electron, the number of unpaired electrons is 2. Now in the Bohr magneton value, how much it will come? 2.83 or 87, whatever you want, you just write it down. This is the Bohr magneton for first one. For second molecule, you just write it down. For manganese, the oxidation number you have to find it out. So X, and this will contribute -1 because NCS, right? We have the spectrochemical series. If you have C, this will contribute -1, right? So -1. So it will be +6 into -1 equal to how much charge it is there? -4. So it will be X -6 equal to -4. So X will be -4 plus 6. It will be +2. So manganese also we have +2 charge. Now just split it, and we know that this is a weak field again. This will be T2G and this will be EG. Down it will be 3, then 4 and then 5. So manganese it will be D5, right? Manganese 2 plus will be D5. So total 5 electrons. So number of unpaired electron is 5. So what will be the Bohr magneton value? It will be 5.92 Bohr magneton. Okay, 5.92 Bohr magneton. So which option will be correct for this? 2.83 Bohr magneton and 5.92 Bohr magneton. Okay, option D. So for this question, option D will be your correct answer. Okay, we'll see the next question, what they have asked. Okay, the complex that doesn't obey the 18 electron rule. This will take very less time to solve. Okay, this is also from 2021. Okay, we are solving questions from 2021. So this question, let me solve the complex that doesn't obey the 18 electron rules. 4 options you can see in a screen. Okay, one by one I'll take and we'll see whether it's a following 18 electron rules or not. So first we'll take the option A. Okay, for option, this is the question number 12, right, from 2021. So we have this 5 means, eta 5 means the 5 electron it is contributing. Okay, H5 and then titanium 4 carbon minus. Okay, this minus will be here. So for this we have to just calculate whether it's following 18 electron rules or not. Okay, so titanium, how it is called? Is scandium, then titanium. Metal in +2, this will be D1, this will be D2. So this is D2. If we remove that +2 state, oxidation state, so it will be, total contribution will be 4 electron, right? So now will titanium, it is 4 plus this is contributing 5 electron plus this is cyclopentadienyl. Okay, so 5 electron, and this is contributing 2 in each because lone pair it is contributing, right? So 2 in each, so 2 into 4. So how much? 8. And then 1 electron is there in peripheral. So you have to add it up, right? So how much it is coming? 4, 5, 9. And 8, it is 17 and 1, 18. So this one is following 18 electron rules. This is MCQ, right? So only one option will be correct. So option A itself is correct, but we will solve for all. Okay. Option B, okay, doesn't obey. Okay, we have to see doesn't obey. This is obeying, right? We have to find doesn't obey. So this is not the correct option. So option B, just we will find the manganese and then SnPH 3 twice, and then it will be carbonate 4 times, and here also it is minus. Let me see. For manganese it is metal in +2 state, it will be D5. So overall it will be D7. Okay, total valence electron will be 7. So 7 plus, from here how many electrons it will contribute? 2 electron it will contribute. Here it will be 4 into 2, 8 electron, and 1 electron you just add it up. 7 to 9 and 8 and 9, 9, 18 electron. Okay, so here also it is obeying 18 electron rule. So now the option C, what is there? Eta 5 and then C5H5. Okay, iridium and then CH2 it has given, and then we have Me3. Okay, no charge on top. So how much it will come? Just iridium, right? Iridium it will come, where it will come? Cobalt, rhodium, iridium. So it will contribute your cobalt, rhodium, iridium. So 9 plus this is 5, and this is not CH3. If it is CH3, 1 electron it will contribute. It is CH2 means 2 electron it is contributing, right? So plus 2, and plus this is a lone pair it is contributing from phosphorus, so it will be 2. So 2, 2, 4 and 5, 9 and 9, 18. So this is also obeying the 18 electron rule. Now for option D we'll see. Option D will be tantalum, chloride, P, Pt3, and then CH, C, Me3, vanadium, niobium, tantalum. Okay, vanadium, niobium, tantalum. So this is scandium, titanium, and vanadium, right? Scandium, then titanium, then vanadium. So it will be metal in +2 state. It will be D3, right? So D3 for tantalum also metal in +2 state. It will be D3. So 3 plus 2. So it will be 5. So it is contributing 5. Plus this is contributing 1 into 3. So 3. Plus this one is contributing 2 electron. Okay, and plus here it is contributing CH and then CMe3. So it will be like this, one hydrogen and this side CMe3. So 2 electron it is contributing. So 2. How much it is coming? 5, 3, 8, 8 to 10 and to 12 electron it is contributing. So this is not obeying 18 electron rule. So your correct option will be option D, which is not following your 18 electron rule. Correct? Okay. So from 2021 we have many questions, like total 10 questions is there, then 2025 questions are there, and 2019 5 questions are there. I think it will increase the video length, and for me, like a newbie in YouTube, it won't allow me like beyond hour and hour, right? So what I'll do, I'll just cut it here itself, and tomorrow in the same time, because you know, right, every day 7:45 p.m. I'm online, right? So every day 7:45 I'm online. So tomorrow it will be like only PYQ I'm going to discuss, because only leftover is PYQ itself. So the whatever concept I am given, based on that, the PYQs I'll solve it. So just bear with me, and I'm sorry for that today I'm not able to complete it, but definitely tomorrow it will be completed, because this video, I hope, I'm not sure that how much length it is already completed, but it will be more, I guess. So tomorrow at same time 7:45 you will be seeing this video for the remaining questions till 2019. I'll solve. Okay, I'll solve all the questions. Correct? So thank you for watching.